So here it is actually given that the diagonals bisect each other at right angles. It means that it is also given that AC is perpendicular to BD also. AC is perpendicular to BD. So it means that I can say that angle AOD equals to angle AOB, that is equal to 90 degrees. So here we can also see that therefore in triangle AOB and AOD, triangle AOB and triangle AOD, angle AOB that is equal to angle AOD, which is equal to 90 degrees. Since it is given that AC is perpendicular to BD. O is the common side. O is common side and OB equals to OD. OB equals to OD. Hence it is divided. Therefore, I can say that triangle AOB is congruent to triangle AOD by SAS rule of congruency. SAS rule of congruency. So we can say that AB is equal to AD by CBSE. And here we have also shown that AD equal to BC also. And since ABCD is a parallelogram, the opposite sides are equal, as AB equal to DC also. So AB equal to DC also, since ABCD is a parallelogram, which is proved above. Is proved above. So we can say that all the sides are equal. AB equal to AB equals to AD equal to BC we have shown. So AD will be equal, so AB equal to AD, which is equal to BC, which is equal to DC. Therefore, I can say that ABCD is a rhombus, since all the sides are equal. So hence proof. Then in question number 4, it is told, show that the diagonals of a square are equal and bisect each other at right angles. We have to draw a square. Suppose ABCD is a square. The diagonals bisect each other at right angles. So in a square, each angle is a right angle also. Therefore, so it is given that AC and BD are the diagonals or the two diagonals of a square ABCD. Square ABCD. So we have to prove that the diagonals are equal, means AC equal to BD and they bisect at right angles. AC is perpendicular to BD also, and when they bisect each other at point O. And it is given that AC and BD are the diagonals of a square ABCD which intersect at O. Intersect at the point O, and we have to prove that they bisect each other at the point O. and they are equal also, and they bisect each other at right angles. So the proof is that we will take in triangle DAB and triangle CAB. In triangle DAB and triangle CAB, have that angle DAB is equal to angle DAB and angle CBA. In triangle CBA, DAB is equal to CBA, which is equal to 90 degree. So these two are 90 degree. So 90 degrees, since each interior angle of a square is a right angle. Each interior angle of a square is a right angle. And you can say that AD equals to BC, since all sides of a square are equal. All sides of a square are equal, and AB is the common side. AB is the common side, so therefore I can say that triangle DAB is congruent to triangle CBA by SAS rule of congruency. By SAS rule of congruency, so we can say that AC equals to BT by CTCT. AC equals to BB by CTCT. So hence the diagonals are equal. So now we can say, now in triangle OAP and triangle OCB, we have angle OAD that is equal to angle OCB, and angle ODA that is equal to angle OBC. OAD that is equal to OCB and ODA equals to OBC. Since why the alternate interangles are equal, since AD should be parallel to BC, since a square is a special type of a parallelogram only. Since we can say that alternate interior angles are equal as AD is parallel to BC. This AD is parallel to BC since opposite sides of a square are parallel, since a square is a special type of a parallelogram. All the sides are equal. And we can see that AD equal to BC. AD equal to BC also. Yeah, since all the sides are equal, since all sides of a square are equal, sides of the square are equal. So therefore, we can say that triangle OAD is congruent to triangle OCB by ASA rule, an angle side angle, and ASA rule of congruency. ASA rule of congruency. So therefore, we can say that OA equals to OC and OB equals to OD. OB equals to OD by CBSE. Hence, we can say that the diagonals will bisect each other. So I can say the diagonals AC and BD bisect each other at the point O. Bisect each other at the point O. Then so now we can take triangle AOD and AOB. Now triangle AOD, triangle AOD. AO is the common side. AO is the common side. And OB equals to OD. OB equals to OD, which has been proved above. And angle AOB equals to angle AOB. Angle AOB equals to angle AOB. You have to show that. Okay, OB equals to OD. AD equals to AB. AD equals to AB since ABCD is a square. ABCD is a square, so all sides are equal. Therefore, I can say that triangle AOB is congruent to triangle AOD by SSS rule, by side rule of congruency. I can say that angle AOB equals to angle AOD by CBSE, and also angle AOB plus angle AOD, that is equal to 180 degree, since they are corresponding a linear pair. So therefore we can say that angle AOB is equal to angle AOD. So Therefore, we can say that angle AOB equals to angle AOD. AOB equals to angle AOD equals to 90. Hence, we can say that AOB equals to AOD equals, okay, here AOB equals to AOD is equal to 90 degrees. So hence AC is perpendicular to BD also. In this case, AC is perpendicular to BD. So hence these diagonals are equal, we have shown, and they bisect each other at the point 2, that also we have shown. And they bisect each other at right angles, that also we have shown. So hence AC is perpendicular to BD and AC is equal to BD, and also AC and BD bisect at the point. So hence BD. Then here it is told that if the diagonals for square are equal and bisect each other at right angles, then it is a square. When we take a quadrilateral ABCD such that if diagonals are equal, is that diagonals are equal, is O, they are equal and they bisect each other at right angles. They bisect each other at right angles. Then you have to show that it is a square. So it is given that in quadrilateral ABCD, the diagonals AC and BD bisect each other at the point O, so that AC is perpendicular to BD at the point O. So they are bisecting at right angles also, and the diagonals are equal also, means AC equal to BD also. So then we have to prove that ABCD is a square. The proof is that we take in triangle AOB and triangles COD, we have that. See that OA equals to OC and OB equals to OD. O equal to OC and OB equals to OD. And angle AOB that is equal to angles COD is equal to 90 degree. Angle AOB equal to angle COD which is equal to 90 degrees. Equal to 90. So therefore I can say that triangle AOB is congruent to triangle AOC, triangle COD by SAS rule of convention. Okay, so here OA equal to OC, OB equal to OD, since it is given, and OB equal to COD equals to 90 degrees, since it is given that AC is perpendicular to BD. And also AOB equal to COD, since they are vertically opposite angles, that also we can say. Since they are vertically opposite angles are equal. And so AOB is congruent to COD by SAS rule of convention. AOB equal to COD by SAS rule of convention. So we can say that AB equal to CD and angle OCD that is equal to angle OAB by CPCD. And so therefore we can say that AB is parallel to CD. AB is parallel to CD since the alternate interior angles are equal. The alternate interior angles which are that is angle CT, which means angle ACT is equal to angle OAB, which means CAB. AB. The alternate interior angles are equal, so AB is parallel to CD. So I can see that in quadrilateral ABCD, two opposite sides are parallel and equal, which means that ABCD is a parallelogram. Therefore, I can say that in quadrilateral ABCD, quadrilateral ABCD, opposite sides AB equal to CD and AB is parallel to CD. So I can say so ABCD is a parallelogram. Since two opposite sides, since two opposite sides are equal and parallel. Two opposite sides are equal and parallel. Since two opposite sides are equal and parallel, AOB equals to AOD. CD is a parallelogram. Opposite sides are equal and parallel. So therefore, I can say that AD is parallel to BC also, and AD is equal to BC also. Also, we can see that um, each each of these triangles, OAB, OCD, these are right angle triangles, and these two sides are equal. So these two angles are also equal. So each one is 45 degrees. So this is 45 degrees. So it means that each interior angle is a right angle, and it is a parallel,